Let's get started with the ones in this video, shall we? First, we got the static nested class. Static nested class is like any static member. It's declared on class level using the keyword static. Here are some important things you need to know about static nested class. It is treated as a static member of its outer class, as already said, so basically the rules for static methods apply to static classes as well. A static class can have all types of access modifiers in its declaration. Here is the moment to point out something that should be obvious by now, but I want to make sure I've said it. Static classes can only be defined on the class level. It can't be inside a method. I suspect you figured out already, but still. Static class only have access to static members in its enclosing class, because of the nature of the static keyword. That's not really strange, as I already mentioned that the same rules apply as with static methods. Static classes can define both static and non-static members itself. A static class can be accessed without instantiating the outer class. Instantiating a static nested class inside its outer class can be done without the outer class as a prefix. Talking about instantiating a static class, let's examine the two pictures we have. In the first one we have outer class. Inside it we have static nested class, which is static nested class. We also have one additional method, just for the sake of example, which is called access nested method. As you can see, we can directly instantiate the static nested class and access its method. I'm just showing you that because once we take a look at the next picture, things are starting to get a little creepy regarding the syntax. We are trying to create an instance of a static nested class outside its enclosing class. The syntax is a bit strange, as you can see. For the reference type, we have outer class dot static nested class, and for the object type we have new outer class dot static nested class. I know what you're thinking. The syntax is strange, it doesn't really fit into the whole Java world, but it is what it is. This syntax basically means instantiate static nested class named static nested class, which is inside the class named outer class. As we said, we can instantiate the static nested class without needing an object of its outer class, so that's just how we refer to static nested classes while trying to instantiate them. Okay, after this strange thing, let's continue with another type of nested classes. Non-static nested classes are also called inner classes. An inner class is associated with an instance of its enclosing class. Thus, to instantiate it, an inner class, you must first instantiate its enclosing class. Here are some important things about inner classes. Inner classes are associated with an instance of its enclosing class, just like instance methods and variables. So basically, we can't create an instance of an inner class before creating an instance of its outer class. It can't have all types of access modifiers in its declaration. An inner class has access to all the members of its enclosing class, including private and static members. If you think about it, it's quite logical. Methods in a class have access to the private fields and methods of its enclosing class. So, yeah, no surprise. It can only define instance members. That's just a rule. There are many debates whether this is logical or not. The general opinion is that there isn't any good reason to support static members inside an inner class, but also there isn't any good reason not to support it. So, again, it is what it is. Instantiating an inner class inside its outer class can be done like a regular class. Let's look at the picture to the right again. We have absolutely identical example as in the previous slide, but this time it's not a static nested class, it's non-static nested class. As we see, we can instantiate it freely into the access nested method. If we try to create an instance of the inner class outside of its enclosing class, things start to get a little more complicated, but not like the static nested class. Here, the syntax is more logically structured. We need an instance of the outer class to create an instance of the inner class, right? So we first instantiate the outer class, and then from that object we call the constructor of the inner class to create a new object from it. Finally, we call methods on the inner class object. Again, the reference is outer class dot inner class, which is okay syntactically. We can do it all on one line, which looks a little stranger, but still, in my honest opinion, way better than instantiating static nested class. Let's continue. Method local class is a class which is declared in the block of code of a method. As the name suggests, it is visible only in the block of code of the method in which this class is declared in. Here are some important things to know about method local classes. It cannot have access to modifiers in its declaration, as with local variables. It can access all the fields and methods of its enclosing class, static and non-static. It can only define instance members. From Java 8, method local classes can access local variables and parameters of its enclosing method, but only if they are final or effectively final. Effectively final is a variable which doesn't contain the final keyword in its declaration, but for its entire lifetime, its value doesn't change. Let's look at the example. Our inner class can use the variable name, declared in its enclosing method. It's not declared final, but it's never changing its value, so it's effectively final. What will happen if we try to change the value of name, even after the method local class declaration? We will get a compile time error. Why this is happening? Well, it's quite advanced subject and not really easy to understand, but let's just say that it's a limitation of Java. Local variables exist only for the lifetime of the method in which they are declared, so using them inside the method local class or anonymous class, which we will learn later, we'll be forced to make a copy of the variable inside that class. So changing the original value may lead to an error, as the copy inside the local class is having different value from the real one. Yeah, I know, it's hard to understand. I had struggles with it for a very long time, but happily, the solution is quite simple. Just try to use only final or effectively final local variables in the local classes you create. This will fix your problems. Otherwise, the compilation error will tip you that there is something wrong. That was all about nested classes in this video. We still have one more thing to learn though. Did you consider the situation where a nested class and its enclosing class or method are having variables with the same name? No, this will not lead to a compilation error. This is absolutely valid situation. If a nested class and its enclosing class or method have fields or methods with the same name, the fields or methods of the nested class are set to shadow over the fields and methods of its enclosing class. Here are a couple of guidelines to avoid shadowing. The this keyword inside an inner class refers to the members of itself, not the members of its enclosing class. Outer class.this used inside an inner class refers to the members of its enclosing class. Static members of the inner class are not shadowed, so we can refer them directly. To refer static members of the outer class, we should use the outer class as a prefix, as a normal static member. If there is inheritance involved, the same rules apply for the super keyword as for this keyword. If you are confused, just look at the example and the output. We have outer class having instance field SumInt and private field SumStaticInt. We also have inner class called inner class, which again is having instance field SumInt and static field SumStaticInt. Please look at the access fields method to see how we can access the different fields. To access SumInt of outer class, we use outer class.this.SumInt. To access SumStaticInt of outer class, we can do it as normal static field using the class name as a prefix. To access SumInt of inner class, we are using this, as this refers to the object of the inner class. No need to explain how we access some static int from inner class, I think. If, for example, outer class extends another class which has field with name SumInt, we could access it using outer class.super.SumInt. It may sound a bit confusing, and to be honest, before making this video, I had to write myself some code before being able to remember how it's done, as this is normally not happening very often. So my suggestion is the same. Open your IDE and code. That way you won't rely on my explanations, and you will be able to see from first hand how it's done and use your visual memory.
For more details, check the link in the description. Learn with Whizlabs. Success certified.